Well, I messed this video up. I was trying to improve the camera settings and lighting, but instead I didn't realize until it was too late. It came out very dark, very grainy, so I only had two choices. I could forfeit this entire mailbag because changing simple things like brightness, contrast, color tinting, saturation, I still couldn't make it viewable until I applied this filter that makes it look like an old vintage film. So if you don't mind taking a trip down memory lane this one time, go get some popcorn, sit back, and enjoy the film strip. And we start off with One Piece's storage box case cover, and it's kind of hard to get into, but it looks like a big battery holder. So it holds a couple of D cells, those big ones for big flashlights and things like that. But I figure if I need about 3 volts, maybe to power a little wireless module or something, maybe because I want to just place it somewhere in the corner and forget about it, and I want it to last a long time, I'll have a lot more battery capacity out of a couple of D cells. Good thing to have just in case I ever need it anyway. I've already got lots of AA and AAA holders, so D cell holders. One Piece's 2x 1.5 volt D battery holder box case with wire lead. $1.99 from misc. I'm not sure if it was $1.99 when I got it. This is another one of those items that's been sitting in an envelope here for a very, very long time. So I'm finally getting around to opening it. I only have a couple of envelopes left from way back up to a year ago. So when I need to get a lot more current at 3 volts, this is one way to go about it. And module times 1. I look forward to always opening modules. This looks like a standard module with some header pins. And I can't seem to get into it, so let's try that. Okay, 2 rows of headers, and it looks like those would go along the outside edges here. But I'm wondering, is it breadboard spacing friendly? It looks like it is breadboard spacing friendly. So what is it? TCA 9548A. Looks like we have power, I2C, reset, address, 0, 1, and 2. Wait a minute, there's a bunch of serial clock and data. I2C expander, CJMCU 9548, TCA 9548A, 128 I2C 8-way multi-channel expansion board I2C mod P017. $2.29 from Lucky Warm. This took 7 weeks to get here. I did not pay shipping. This device is useful when you have multiple items that all share the same I2C address, and you can only have one address on the bus. And briefly looking at the datasheet for the part, it's basically an 8-channel I2C switch where you can route the traffic coming in on the bus to any of those 8 devices. And it allows you to share between devices even with the same address because they're all going to be on their own channel anyway. Or you may want to separate your I2C buses because you have different voltages. If you have some 5 volt I2C items and some 3.3 volt I2C items and they can't tolerate or operate on each other's bus voltage, then you can put them on their own dedicated channels with their own pull-up resistors to those supplies and it'll all work fine. There's not much surprise about what's in here based on the description. Z or Z80. And that looks about right. I use Z or Z interchangeably sometimes. In the alphabet song, Z does not rhyme, but why is it called Z in the first place then in some places? I don't know. But I'd like to be able to see the markings. But for once, at least the pins are straight on something I receive, especially one of a kind. I've never had one of these, I've never used one, so this is the one and only Z80 CPU. So I'm not sure of how many variants there might be to this base chip, but there's the actual part number I have, and I just wanted this to have around, which I say a lot. It might be fun to try to get something like this up and running on a breadboard and write a little simple code for it. Start out with a Hello World LED blinker at some point, but at least now I have one more than I had a couple of minutes ago. So this will go into my standby parts reserve for interesting things to play around with whenever I need a new project and I can't think of one. I'll spend all day trying to blink an LED. 1 pieces Z80 CPU microprocessor IC ZILOG DIP 40. No need to go through all that. $1.30 from Polita. I think I had trouble trying to pronounce this before. 2008. This took 6 weeks to arrive, and I think we all are somewhat familiar with this. It's an 8-bit processor from the 70s. It was a software-compatible device to enhance the Intel 8080. It was aimed at embedded systems, so it could go into printers, cash registers, telecom, computers, arcade machines, music synthesizers. I never worked with one of these, so I'd like to try it out. The ever-descriptive electronic components are in here. So we have 5 chips. What kind of chips do we have? The kind we can't easily get out of the tube. Okay. I think it says TCM 5089N. I think this is a DTMF touch tone signal generator, and that will be part of my phone line simulator experiments. I'm going to be doing touch tone decoding to detect what touch tones are being sent by a modem, but I thought maybe at least for testing purposes I might actually want to be able to generate those touch tones as well. 5 pieces TP5089N DTMF touch tone generator, 16-pin DIP. $3.56 with no shipping from Adele Parts 2010. And this was ordered forever ago, and it's been sitting around, so I have no idea how long it took to get here. But it took me about 8 months to get around to opening it, so this is a long, obsolete part. It's used to hook up to a keypad on a telephone or any other similar device that generates DTMF touch tones, and it will read the keypad and generate the output combination of 2 tones for the DTMF signals. It operates 3.5 to 10 volts, so that's convenient. It needs a 3.579545 megahertz crystal, and it does pretty much all the rest. And this was designed for a certain kind of keypad. It's not apparently a row-column scanning matrix. This keypad has a connection to ground. I've never used one of these. I don't know what the internal workings are, but apparently the way this chip works, there's internal pull-ups on all of these row and column pins, and when you bring a column and a row to ground, however that happens in here, that's when it detects that certain key press. So that actually makes this convenient to use not for manual entry, especially if you can't find one of these kind of keyboards, but for a microcontroller. All we have to do is leave this high impedance and allow the internal pull-ups to keep it high, and then we just generate a low in whatever combination to generate DTMF tones. So a key closure is recognized when a single row and a single column are connected to ground. And this is how I'm probably going to be using it, something like an Arduino controlling the row and column to generate the tone output. Electronics quantity 1 are in here. Wires! I've already got a couple of things. I think I received a set of just black and red, and those might have been shorter, but this is more colors of the same sort of thing. As with last time, being tinned on each end, I could try to stick these in breadboards, but more importantly, if I'm soldering onto something like a potentiometer, and I just need something without running around looking for wires and stripping them and twisting them and trying to tin them, this is all ready to go basically. Maybe just touch it up and then just solder it onto some pins of something you just need to get quickly attached to. Stuff to have around. Always useful. 100 pieces, 20 centimeters, new, color, flexible, 2 ends, tin-plated breadboard jumper.
100 pieces, 20 centimeter, new, color, flexible, 2 ends, tin-plated breadboard jumper cable wires.
$2.31 from Love Cell 2013. 5 different colors, 20 of each color. Maybe these can be used in a breadboard, maybe not, but I'm mostly going to use this just when I need something available to solder onto something and I don't really want to mess around trying to cut off of a bigger spool and trying to find multiple colors if I need to color code something, I'll just grab something out of a pile like this. These took 7 weeks to get here. Another expansion board module. This one might be a Hall effect current sensor. It's got screw terminal on it and it kind of looks like that style board, and I've been waiting for it. So what do we have here? A screw terminal, VCC ground, and out. So something will be happening from here and there's going to be an output. I can't seem to get this on an angle where I can read this between the glare or the faint writing. ACS 712, that is indeed a Hall effect current monitor. And this, I just put Scotch tape over there. I saw this trick somewhere online years ago. If you have trouble reading part markings, one of the ways around that is to put Scotch tape. 5 amp, 20 amp, or 30 amp range current sensor module ACS 712 for Arduino, Raspberry Pi, and Uno. I have the 5 amp one, and there's several styles here. This one's $1.45. This one with fancier terminals is $2.12. And this one is similar to the first one. It's $1.59 from DIY Box. It took 8 weeks to arrive. The ACS 712 is now obsolete. There's a replacement, the ACS 723, for designs, but on the workbench, this works fine. So you give this 5 volts and ground, some filter capacitance, you put your circuit that you want to measure current for in line just like you would with a multimeter, then you get a DC output voltage proportional to the current. There's only 1.2 milliohms of internal resistance. You can have AC or DC current. So with this plus or minus 5 amp current sensor, we get about 185 millivolts on the output per amp. When we are at 0 amps, we get 2.5 volts out. And whether we're going plus or minus in the current, we will go toward 5 volts or toward ground by 185 millivolts per amp. So if we're measuring a complete 5 amps, 5 times 185 millivolts per amp is 0.925 volts plus our original starting position 2.5 equals about 3.425 volts out. So if we were to connect this to an analog input on an Arduino, whatever voltage we measure, we can use that formula, 185 millivolts per amp, with 2.5 volts being 0 amps, and calculate how much current we are sensing. All right, we can hold a couple of D cells and get a 3 volt high current capacity power source. We have a nice breadboard friendly I2C switch where we can break out a single bus into 8 channels. We have touch tone generating chips, 5 of these, Z80 processor for blinking LEDs and hopefully more, a bunch of pre-tinned hookup wire, and a current monitor IC. Lots of stuff to allow me to do lots more stuff.